Here we have our defined cam part with added face milling operation from the previous Jumpstart videos. For the second operation, let's use SolidCAM's profile technology to machine the outside contour of this part. Go to the SolidCAM Manager. Right-click the operations header and choose Profile from the Add Milling Operations submenu. When the Profile Operation dialog box appears, you'll notice that the workflow is quite similar to what we saw when we defined our face milling operation. Of course, we'll start off with defining the geometry. To do that, we'll click the New button. Now, after the Geometry Edit dialog box appears, in the SOLIDWORKS graphics area, you have to pick on a chain that runs along the outside contour of the target model. When making the geometry selections, there are multiple options available to us, and we'll discuss two of those options in this example. The first option is to start by selecting the initial edge. Then, one at a time, pick and highlight all subsequent edges until we have worked our way back around to the beginning to finally close the chain. Take notice that when we selected our first edge here, this red arrow appears. This arrow represents machining direction, and you should be aware of whether you want to perform a conventional or climb cut. For this example, let's make sure that we're climb cutting since SolidCAM mills on the left side of the geometry selection by default. You'll see this when we get to the technology page. Also, the point where the mouse arrow appears when we selected the first edge will be the initial XY position in the generated G-code. This basically gives us control over where we want the profile machining to begin. Now, we can take a look at our second option of chain selection, Auto Constant Z, which is probably the most used option when defining geometry chains for 2.5D milling technologies. First, we have to reject our initial chain by clicking the Reject Chain button in the Chain List section. Let's start again by picking on the top edge of our target model in the SOLIDWORKS graphics area. Using the Geometry Edit dialog box, select Auto Constant Z, and then click Yes to accept the selection. Auto Constant Z will close the chain by automatically selecting all connecting entities on the same Z level. With one easy step, we were able to create this entire chain. We'll see that Chain 1 appears in the Chain List section, and now we know that the machining geometry is defined. Our toolpath will work around this chain. Let's click OK to exit the Geometry Edit dialog box. Next on the list, we need to create our tool. Move to the Tool page, and then click the Select button to start the tool definition. The only tool we have defined so far is a face mill, which would not be suitable for profile machining. So again, click the Add Milling Tool button to add a new tool to the Part Tool table. Choose End Mill from the Milling Tools list. For this operation, we'll use the default values, which provide us with a 6mm diameter tool. Let's now click Select to choose the tool for the operation and exit the Part Tool table. With the tool now defined, let's move on to the Levels page. We'll again pick our milling levels right off the model. To start, click the Upper Level button. Then, we need to pick the feature that represents where we want the machining to begin. In the SOLIDWORKS graphics area, select the top face of the target model. Click OK to accept the selection. Next, let's click the Profile Depth button, and then pick the feature that represents where we want the profile machining to stop. In that case, we should select the bottom edge of our model. Click OK to accept the selection. In the Milling Levels area, there is the option to enter a delta depth, which is available to control profile depth even farther. For example, let's say we wanted to leave an extra 0.5 millimeters at the bottom of our part. Enter 0.5 millimeters in the delta field, and our tool will feed in the Z-axis 0.5 millimeters short of the profile depth. We can otherwise enter negative 0.5 millimeters, and our tool will feed 0.5 millimeters past the profile depth. The direction of the delta depth measurement is represented by the arrows next to the input field text box, with a corresponding positive or negative symbol. It is also represented graphically here on the left. For this example, let's set the delta depth back to 0. Next up in our workflow is the Technology page. Starting in the Modify area, the Tool side controls what side of our selected geometry we will mill on. Our choices are right, left, and center. we'll use the default selection of left. Under depth type, we also have three options: constant, define, and helical. The selected strategies are represented graphically in the lower left corner of the operation dialog box. Again, we'll use the default selection, which is constant in this case. If we activate the rough checkbox like so, we can do both a rough and finish pass. We can leave material on the wall and floor, then have the tool come back and machine off the excess material. For this example, let's enter a wall offset of 0.24 millimeters. Let's also input a step-down value of 3 millimeters, half the tool diameter. We will leave the number of passes for our finish cut at 1, meaning our tool will come down to the full profile depth and remove the 0.24 millimeter offset on the wall in a single pass. Lastly, we should move down to the link page. If you click the drop-down under Lead In, you'll see that there are 6 available options. Whatever option we select, the illustration on the left gives us a visual representation of how the tool will approach the material. For this example, go ahead and select Arc for the lead in, and then set the radius value to 4 millimeters. This means our tool will make a 4 millimeter arc into the profile cut. Now we have the exact same options available to us under Lead Out. To simplify the selection, just enable the Same As Lead In checkbox. This will make the Lead Out type equal to the Lead In type. Now, let's click Save and Calculate to add our profile operation to the CAM tree and calculate the tool path. Next, we should simulate the tool path to ensure that the result is what we want. To start the simulation, click the Simulate button. As we click the Play button, we should see the tool make 3 profile passes around the part and then come back in to perform the final finish pass. Now that we know everything looks good, let's close the simulation and profile operation dialog boxes by clicking Exit for both. Next up, we'll add a pocket operation to our CAM part, which will get us even closer to completing the part programming.